This is Shakil Ahmed. In this tutorial, we will discuss about classification and regression tree. The cart is used for classifying a qualitative or a categorical variable, and as well as if we have a continuous outcome, then it will perform a regression task. And if the outcome variable is a qualitative variable, then it will perform the classification task. So we will perform a classification task on the strokes data. We can classify the patients whether they have stroke or not on the basis of the data provided in this data set. So classification, uh, what are classification trees, and when we need to build a classification tree. So a classification tree is a type of decision tree that is used to classify a categorical variable or a binary variable uh, using a set of predictors or features we have, and it's just an alternate of the logistic regression. Basically, logistic regression assumes a specific parametric form about for modeling the logic of the outcome to the logic of the function of the odds to the axis with the features. But the random forest, or we will later discuss the random forest, the classification and regression tree use a recursive partitioning of the sample space based on different conditioning on the predictors, and then we will get homogeneous nodes, and then we will see whether a new observation goes in on a node. On a given node, we make a decision whether if the problem is classification, then we will see how many variables, how many instances or observations are having the same characteristics. For example, we have a data on strokes and non-stroke, and on a final node we get, for example, 5 observations with 3 strokes and 2 non-strokes. Then based on the majority vote, we will declare the new observation on that node as the stroke. So this is an attractive feature. It captures the non-linear relationship between the classification variable or the binary variable and the predictors. So we do this analysis using Python, and we need to import the pandas package and model selection. For train test split, we basically train the model using the training set, and then we test the predictive performance of the model on the test set. And then from the scikit-learn tree package library, we import decision tree library, and from scikit-learn matrix we import the accuracy score. We can also import other performance measures as well. So we can drop the ID column, so we don't want to use it in our analysis, and we select some most important variable related to strokes like gender, ever married, work type, residence type, and smoking, and then we encode them using the encode command to make them dummies, and 1 and 0 for simplicity. And then this is our x variable consists of all the variables in this data frame excluding the stroke, and then uh, in the data about data frame, and then we extract y as stroke as y, and then we split the data into test and training. keeping 20% in training part, test part, and training the model on the remaining 80% of the data. So then we will run a model decision tree classifier that we have already imported here, and then random start with 42, that is for random number generation. You can set another other numbers as well. And then model fit, we have two inputs, x train and y train, and then we can predict the y values based on x test. So we can just run this command. So giving some error, I think we have not yet uploaded our data, I think. So now we can run. Right now. Now it is working, and then we can predict the see the predicted values. Mostly values are 0. Mostly observations are predicted as non-stroke, that is 0. So these are the observations from the test set, basically. Y based on predicted based on X test. Basically, we have X data on these patients, and we want to see what is their status. That is, they are non-stroke based on their variable included in the model. For example, these are the variables. All are the variables we included in the model, and we can see the accuracy of the model. It's 0.91, almost 91.5% accurate result it's giving. It means the accuracy is basically the in confusion matrix, the main diagonal, sum of the main diagonal divided by total number of observation is the accuracy. Total number of correctly false true positive and true negative. The sum of true positive and true negative divided by total number of observation, that is the accuracy, and we can divide it the total number of observation to get the percentage. And we can see a confusion matrix as well using the uh, classification report library and confusion matrix. This is the classification report for the two groups. We have this classification, this value of the precision, recall, and F1 score, and this is the accuracy at after averaging for the two categories, and then a weighted average of the two categories. But this is the confusion matrix. You can see 923 patients are correctly identified as non-stroke, and 12 patients were correctly identified as stroke, as they had stroke and predicted as having stroke. So this is the performance measures, and we have already discussed about precision, recall, F1 score, and support in previous lecture. A high accuracy indicates a good overall performance of the model on the test set, and a classification report provides a detailed summary of the precision, recall, F1 score, and support for each class, offering insights into the model's performance just beyond the overall accuracy. For the two classes, they have separately giving these matrices, and then I'm installing the graphviz to see the tree we have ground for prediction. We can see the tree based for the training data. Basically, we have grounded tree on the basis of the training data. So we need to create a dot data that export graphviz, then model out file none. We are not using any out file, and then feature names. These are the X columns, and then class names. We have two classes, and then field true rounded to true. The values will be rounded. The number of, for example, number of observations if we can see on a specific node, and then special characters can also be read on this data set. And then graph visualize source is the dot data, and then you can see the graph. Here you have the graph. I think it is the graph. So this is the classification tree we have grown for our data. You can see from the center. It's very big to visualize the whole tree. We can just show the start of the tree. For example, we had 238 observations, and we classified based on age, and then we have classified based on smoking, and then we have specified according to BMI. So recursively, we are doing a classification based on many variables, and these are the terminal nodes we are where it becomes pure. We stop the uh, making more trees. So we need to check for the impurity using the Gini index. These are the value of the Gini index. So based on the values of the Gini index, we are partitioning the data, and we checked whether we need to do further partitioning or not on the basis of the impurity. So this is very big tree as the our data set is large and has many variables. So I can show you alternately a simple, more specific format of this graph using matplot library, using PMT, and then plot tree package. And you can put your model object here, and then features, and then class names, and then field is equal to true, and rounded is equal to true. Here I am specifying the file's figure size, so it will be restricted to this size. If you can give the figure size in the above diagram, then it will again be narrow down to a specific, to the specific size. So you can see this figure. This is the figure you can show. This started from this variable, this partitioning, and then second partitioning, and then third partitioning, and you get the terminal nodes with a different number of observations and with different decisions on the terminal nodes. So that's interesting to grow a classification tree. So this is a start, and in next video, hopefully we will discuss the random forest. That is the assembling of many classification and regression trees. So we can do the same problem for the regression analysis, and for the regression analysis, we get the mean values, predicted values, which are the mean of the training data on the terminal nodes. Here, these are the modes. We get the predicted values at 0, 0, 1, 1 means the majority, if the majority values or majority classes are 0 on the terminal node, then this node is declared to be the non-stroke, and then whenever some observation come on to this node, then it will be declared as non-stroke. So for the regression tree, we will get the mean of the continuous variable. Basically, we have a quantitative variable as the dependent variable, so we can find the mean instead of the mode of our that is considered as the predicted value of the y for given set of axes and features. Thank you. If you have any question, you can always ask.